Very good morning, everyone. Guys, we'll wait for a couple more minutes and then we'll start the class. Okay. Okay, guys. So let's start the class. Let me share my screen. Okay. So yesterday we have seen so few plots and graphs of how to plot and do. Okay. So today what we will do is we will learn about the stats, the basic statistics about some distributions and all. Okay. Statistics. Okay. So in the basic statistics, whenever you look into the any statistics, the first thing you will get in the mind is uh, the statistical terms called as mean, median, okay, and more. Okay, these three terms you will be uh, getting. Okay, so first we'll understand about the mean. So mean, you already know mean is nothing but the average you are calculating. Okay, so how you will be calculating? Sum of data points. Okay, all sum of data points, you divide it by total number of data points. Okay, that's the thing we have already done this in the previous class. Okay, what's about the median? Median is nothing but the midpoint in a array. Okay, so first what you will do, you will arrange the data points, arrange the data points in an order, ascending order, and get the midpoint. That's it. What is the midpoint? If the midpoint is two numbers, then you will be getting the addition of two numbers and divided by two. Okay, mode is nothing but most frequently occurred or most repeated data point. Okay, so this is the meaning of the mean, median, mode. So let's load the statistics, Titanic data set. Store it in a variable. Okay, now if you want to, we are having the functions in the pandas, even in numpy. There is no need of remembering all these things. Okay, the manual calculations is not necessary. Directly you can use those functions and you can do the calculations basically. Okay, so see, uh, if you want to calculate the mean, mean fair, Okay, so how you'll be doing? Just fetch that particular fare column dot mean function. All these things. Okay, so this is the average. This is the average. What you will get average fare or average ticket value you are getting. Okay, average ticket value you are getting here. That's the thing. Okay, if you want to know the midpoint, what is the mid value for the fare? What's happening? Data frame of fare median. Okay, what is the median value you have got here? Median value is 14.4. This is the mid value. Okay, this is the mid value. Okay, and data frame of fare dot mode. So 8.05 is a more frequently repeated one. Okay, it has got repeated more frequently. 8.05. Okay, this particular value has got repeated more frequently. So these are the basic statistical terms like we will be using. Okay, so let's understand the limitations of these. Okay, so see, mean and median, always remember they are prone to they are prone to outliers. Okay, they are prone to outliers. Okay, nothing but they are very sensitive. We can call it as very sensitive to outliers. Okay, if you are having outliers, then these may get deviated, then mean and median may get deviated. Okay, whereas mode is not sensitive to the outliers. Why? Because the outliers are very few, but mode you are using it is calculating the most frequent value, most occurred value. Okay, that's the thing. And the mean and medium, always remember that they are very sensitive to the outliers. Okay, so the calculation will get deviated if you are having the highest outlier or very least outlier. That you need to remember. Now, this is the limitation, and uh, I think we are good. So if you want to know this basic statistics, so there is a function called as data frame of pay dot describe of describe. So what this function will do is it will give you the count. What is the count here? 891 rows you are having. What is the mean value? Okay, what is the mean value? What is the minimum value? Minimum value is 0. What is the max value? And yesterday we have seen the box plot, right? Box and whiskers plot. Okay, so in the box and whiskers plot, we have seen the 25 percentile, 50th percentile, and 75th percentile. Okay, so it will also give those percentile things here. Okay, and it is also giving the standard deviation. Okay, standard deviation is nothing but how much the data point is been spread in the distribution, nothing but from one point to another point. What is the deviation? What is this? What is the amount of distance? What is the amount of distance from the mean value, from the average value? What is the distance? Okay, so that's what this standard deviation will give you. Okay, the sparsity of the data. the spread, the spread of the data, how much the data is being spread, how much distance the data is being spread. Okay, that is nothing but the standard deviation, and variance is nothing but the square of the standard deviation. Okay, if you get the standard deviation, then you will get the variance. Okay, so we won't go with the variance much because it explodes the data. Explodes nothing but it increases the value of the sparsity. Okay, so that's why we go only with the standard deviation. That's the thing. Okay, so these are the few basic terms where in the statistics we comes to know. Okay, we need to know these things. Okay, now we will discuss about the uh, normal distribution. Normal distribution. So we go to the Wikipedia. No other things. Ah, see, we get to know from these formulas. Okay, so this a normal distribution. See, why we are discussing normal distribution is by default, all algorithms in the machine learning, or instead of algos, all the data points, or whenever you do some surveys for the collecting the data or anything, okay, all the data points in the nature will follow normal distribution. Normal distribution only. Okay, for example, you are conducting a survey. The survey includes like the water consumption in that particular region. Okay, say for that particular survey. So if it is an industrial related area, then water consumption will generally high. Okay, so if it is an residential, a bit less. Okay, so if you are doing such kind of survey, any survey for collecting the data, okay, then that particular data will follow the normal distribution for sure. 99.9999 times the data will follow the normal distribution. It doesn't follow any other distribution. There are some other distributions as well, uh, color, like Poisson distribution, student t distribution, uh, power law distribution. Okay, log normal distribution, logarithmic distribution. There are many distributions are there. If that particular data is not following normal distribution means this particular like this. The waveform will be looking like this. Okay, so all these are normal distribution. The red color line is normal distribution, blue color one, and this green color one. All these are normal distributions only. Okay, if that particular data is not following normal distribution, we will be converting the data into the normal distribution. Okay, there are some transformation techniques. For example, if an data point is following a log distribution, then we have log normal transformation. If a particular data is following power law distribution, then we can convert that data into the normal distribution by using the Box-Cox transform. Okay, there are some transformation techniques where you can convert non-normal distribution into the normal distribution. Okay, why? Because the algorithms are being as it is a pure mathematical formulation, it assumes that data should be of normal distribution only. It preassumes. Okay, it preassumes the data follows the normal distribution. That's why we need to convert the data into the normal distribution. If you want to check whether the data is following normal or not, just plot that. Let's plot it. Okay. Just plot that particular one. You come to know. That's it. Okay. So let's understand what is the normal distribution. What is all about the normal distribution. Okay. So the notation will be like this. Mu stands for mean. This sigma square stands for the variance. Stands for the variance. Okay. And there is no need of all these things. Just you need to remember this particular formula. TDF, probability density function. You already know the probability density function formula you learned in your academics. 1 by sigma under root 2 pi e to the power of minus 1 by 2 x minus mu by sigma whole square. Okay. This is the formula for the normal distribution or Gauss normal distribution, Gaussian normal distribution, or simply normal distribution. Okay. So this is the formula. Okay. So whatever the data points are there, you just apply on this with this particular value, you will get the normal distribution. That's it. Okay. So mean, median, and mode should be the same. If it is same, then it is called as a perfect or standard normal distribution. Okay, perfect normal distribution. If mean value, median value, and mode value, if three are same, if all the three are same, then it is called as a perfect normal distribution. Okay, that's the thing. We will see about the kurtosis, and entropy is not that much necessary. We'll see what is a kurtosis. Okay, so this is how your distribution will look like. Okay, so this is an important graph to understand the standard deviation as well. Okay, so we know that this formula contains mu stands for mean, sigma stands for the standard deviation, and x is nothing but the data point. Okay, x is nothing but the data point. Okay, now, so why the standard deviation is present and what it gives us the data. Okay, some information. Why it is important, standard deviation. Okay, you might have not learned this one in the academics. Okay, see, this is how whenever you plot the graph, whatever the data you have got from the survey or anything, okay, this is how the graph will look like. Okay, say for example the data is following standard distribution, standard normal distribution, or perfect normal distribution for simplicity. Okay, so here this is the mean value. Okay, this is the mu stands for mean value. Okay, so mean plus you calculate the standard deviation. Okay, standard deviation formula is already given here. Where is the formula? Okay, I will give you the formula. You calculate the based on that, you just calculate the standard deviation. Okay, now mean plus one standard deviation and mean minus one standard deviation. Okay, mean plus one standard deviation on x-axis and mean minus one standard deviation on x-axis. Okay, so at this region consists of around 68.2% of data. So maximum percentage of data, that is 68.2% of data, will fall in one standard deviation, plus or minus one standard deviation. Okay, now if you go beyond that, two standard deviation, here also two standard deviation. Okay, now what is the data here? 13.6, 13.6 means 26 or 27.2, 27.2 plus 68.2. Okay, means 99.8% of or 99.9, so 96.4%. 96.4% of data will fall in plus or minus 2 standard deviation. That's the meaning here. Nothing but the sparsity you are is showing here. The sparsity you are showing here. Getting the sparsity, the standard deviation will gives you the sparsity. It gives you the sparsity here. Okay, that you need to remember. So how much amount of sparsity is giving this much amount in the one standard. It is common for all if it is following the normal distribution. If it is following normal distribution, then it is common. Then it is the standard base standard for all. Okay, so within this plus or minus one standard deviation, 68% of data you will have. Plus or minus two standard deviation, 96.4% of data you will have. 96% of data. Okay, and within the three standard deviation you will be having the 98.1 or 92.1 sorry 99.8% of the data. Okay, so that's what the standard deviation will give you the information about. Okay, so this might be asked in the interview, that you need to remember what is the standard deviation will give you the information about the data, the sparsity, the spread of the data. Okay, that's it. That's about the standard deviation. Okay, now normal distribution. So always remember that if you change the standard deviation or the variance, the data shape will also change like this. Okay, it will also change the shape like this, but just just remember this bell shape curve. That's it. If it is the bell shape curve, you assume it as a you assume it as a normal distribution. Normal distribution. Okay, if mean, median and mode are on the same value, then it is a standard distribution, and if it is mean is equal to 0, then it is a perfect standard distribution, or simply standard normal distribution. Okay, so that's about this bell shape curve. Bell shape curve, normal distribution. Now we will see another distribution as well, like power law distribution. Power law distribution. Again, we go to the Wikipedia. This is the power law distribution. This is how the power law distribution will look like. Okay, so this power law distribution, you will get this type of data in rare cases. Like for example, if you uh, if you are doing a project related to the comments classification, like in Amazon or in products, any product e-commerce website, if you take any product, you'll be having a comment. Just by looking into the comment, you need to classify whether it is an positive comment or negative comment. Okay, you need to classify it. So maximum amount of comments, maximum of the comments will be of like negative comments. Very rare you will have the positive comments, or maximum comments will be of positive, the product is very good. Very less you will be having the uh, these comments, negative comments. Okay, either high or either low for that particular product. Okay, so by based on the product, how you will be defining whether the particular product is good or not. Okay, so that particular data falls on this power law distribution. Okay, that data falls on this power law distribution. that you need to convert into the normal distribution. How you will be converting into the normal distribution? Just by applying the log. Just by applying the log. That's it. Okay. So if you apply the logarithmic on the data values, it will convert into the normal distribution. Okay. This is the power law distribution. That is the thing. Okay. And a Poisson distribution, student T distributions, they all follow the same bell shaped curve. So there is no need of converting them into the normal distribution, but because they are derived from this particular bell shaped curve only. They are derived from this one only. So no need of worries about that particular thing. Okay. Clear, guys, everyone till this point? Any questions? Yashwant, Bhavya, Narsimha. What about others? Okay. Now we will discuss about the skewness and kurtosis. Okay. Skewness and kurtosis. We will go with the images. See, sometimes you can see this image is not good. Mm, okay, we go with this one only. Okay, now if you see this particular one, the left side image. So what it is giving you the information, this is also the normal distribution. Okay, it is also the normal distribution only. The if you see this waveform, this also represents the normal distribution. But this one is leaned towards the left side. That's why it is called as left-tailed skew. Left-tailed skew. Okay, this why it is called as left-tailed skew. When you will get the left-tailed skew is if the mean value is less than the median value and median value is less than the mode value. So in this condition, if mean value is less than the median and median value is less than the mode, okay, then it will have this lean. Forget about the mode. Okay, consider only mean and median. If the mean value is less than median, okay, you will get left tailed skew. Left tailed skew. When you will get the right tail like this, if the mean value is greater than median, okay, if the mean value, see, mean value is greater than the median value, that's why you will get the right tailed skew. Right tailed skew. Nothing but here you are having some outliers, that's it. Okay, if you see some wave like this, you are having some outliers. Okay, right tailed means you are having the outliers at the higher value. Left tailed means you are having the outliers at the lower values. That's the only meaning. Okay, if you are having outliers, then only the wave will be, I mean, curve the curve will be like in the shifted, like this, it will be like this. The shape of the curve will be tilted. Okay, it's only because of the outliers, the presence of the outliers. Okay, that's about the left tail and right tailed skew. Okay, next we look into the kurtosis. So kurtosis doesn't, we won't use anything about the kurtosis in the machine learning or in the statistics, but it's just a property. Where is the nice image? Okay, we go with this one. This one. Yes. See, all are normal distribution only. All these are normal distribution only. But if you see this bell-shaped curve, okay, so the standard deviation is more for this bell-shaped curve. The standard deviation is more. Okay, so that's why you will get this kind of curves. This kind of curve when the standard deviation is more. Okay, and for this kurtosis is nothing but the peak value. The highest value will be there, right? The tip, that is the peak value. Okay, so here if you see the highest value, there is not much having the highest value, so that's why it is called as a negative kurtosis. Okay, and this is the normal kurtosis, and if it is having the higher peak value and the standard deviation is very very less, then it is called as a positive kurtosis. Okay, the kurtosis always represents the peak value. That you need to remember, that's it. Kurtosis represents the peak value. Okay, next we will discuss about, or we will plot these graphs of the Titanic data set. Okay, we have the Titanic data set. We will plot the graph. Sorry, import matplotlib dot pyplot as plt. Okay, now plt dot Let me check. Okay, histogram plot of, say for example, data frame of faith. 1 second, guys. I think there will be another way. Let me check. I think in pandas we will have PD, sorry, data frame of fair dot. We are having plot, right? In that plot, uh, what kind histogram? Yes, this is the histogram, or else PDE. See the density plot. Okay, so this is the density plot. See here you are having this kind of. This is also the normal distribution only. This is also the normal distribution only. Okay, but here the standard deviation is very less. That's why you are having the positive kurtosis. This is the kurtosis. Okay, this is the kurtosis, positive kurtosis. Why? Because you are having the highest peak value. In the same way, if you want to get the distribution of h dot plot of kind is equal to KDE. Okay, this is also the normal distribution with a slight deviation. Okay, so that's the thing. Now, if you get the mean, if you get the mean of age, '29, see, somewhere here, you will be having the mean. Okay, somewhere here. This is the mean value. If you get the median value is also around 30, 32, like that. Okay, data frame of age dot median. Okay, 28. See, 29 and 28, they are very much close. That's why you have got a small normal bell shaped curve. Okay, since the data points are very less, that's why you can see some sort of the deviation here in the curve. Okay, if you increase the data points, if you collect more data points through surveys or anything, then it will be a perfect bell shaped curve. Perfect bell shaped curve. Okay, so that one you need to remember. As the data points you are increasing, okay, then the data must follow the normal distribution. It is, that's the central limit theorem statement. Okay, it is not just an ordinary statement. It is, we are having a proof for that. Okay, which is called as a central limit theorem. Okay, as you increase the data points, it will follow, the data points will follow the normal distribution. Okay, that's what the central limit theorem states it. Okay, so this is how you can view this distribution curve for any of the variables, and these distribution curves is available only for the numerical values, not for the categorical values. Categorical values means, if you look into the data frame, sorry. Okay, if you see the name is a categorical value, you are having some alphabets. Okay, ticket is an categorical value, you are having some alphabets. Similarly here, gender, sex is a categorical value, you are having the alphabets. Okay, so you can't find the distribution for this alphabetical values, but for the numerical values you can find the, you can get the distributions, and you can calculate the mean, median, and everything. Clear, guys? So how to plot the distribution, and how to do it, how to analyze the distribution? Any questions? Yes, guys, any questions? Is that clear? Swati, Kumaresh, Jyoti. Yes, guys. Okay then. Uh, now, now in the statistics, we are having a concept. Uh, what it is, I'm not getting 1 minute. 1 second, guys. One second, I'm just looking into this. Yes, coming to the correlation. Okay, correlation we haven't discussed. Correlation. Okay, correlation. You have already covered this one in the academics. Let's have a brief of about the correlation in terms of this data set. Okay. Now, so correlation in statistics, it's very important. Why? Because if you don't find the correlation, then your data might, then your prediction might get something wrong. Okay. The reason behind is that, see, correlation, what it gives us the information is about, see, like you are having three variables means columns. Variables here means columns. Say for example, here, p class is one column, nothing but a variable. Survived is a variable, fair is a variable, and something sibling sp, sib is a variable. Okay, so correlation, what it will give you is the relationship between the variables. The relationship between the variables. What is the relationship between the, what will be the relationship between the variables? That's what the correlation will give you. Okay, means you are having some variables. Say for example, uh, the first one is the first variable is the first variable one. Say for example, price or quantity, quantity. Okay, and the second variable is, see, quantity, and this one 2 times quantity. Okay, you have done something to that particular quantity. Okay, quantity and 2 times of the quantity. Say this quantity is having some values, 1, 2, 3, something values you are having, and 2 times means 1 plus 2, 2. This one will be 4. Okay, this one will be 6. Okay, so you have just transformed this particular column. That's it. Okay, you have just transformed this particular column, and here is your quantity. Okay, so two columns are present. When you feed the data like this into your machine learning algorithm, ML algorithm, so it will have some kind of redundancy in it. Okay, why? Because this particular quantities column is giving you some relation, some information it is giving. Okay, the same sort of information again 2 times of quantity is also giving, but in different format. The same information it is giving, but it is in different form, but overall it is same. Okay, so this is nothing but this particular column has some relationship with this column. Okay, this particular variable, this 2 times quantity variable is having some relationship with this variable. Okay, that is nothing but these two columns are correlated. These two columns are correlated. That is nothing but the correlation. Okay, correlation, relationship between the columns. So we need to find out the correlation value here, and if the value is high, you can drop it off. You can remove that particular column. Why? Because that particular column has been explained by some other column. Information has already given by some other column. Keeping that column is wasteless. Okay, sorry, keeping that column is waste. It's a useless. Okay, unnecessarily it will increase the complexity of the calculation or execution. Okay, that's why we will drop that particular column. So how you will be finding that correlation? Simple, data frame dot cor cor run. Okay, see, passenger id, these two columns are highly correlated. Nothing but they are same columns. Okay, they are same columns. If you compare the passenger id with the survive, okay, it's completely different. It is also least value. Okay, so check the values which are having very much nearer to 1, very much nearer to 1. So you can't find any such value here. Okay, see, p class is there. P class, if you compared with the survived negative, age negative, sibling negative, I mean positive but not very close to 1. Okay, so like that you can verify. Like this you can verify, and you can compare between these two columns. Okay, you can compare between these two things between the columns. Okay, and you can drop those columns which are highly correlated with the other column. Okay, any one column you can drop. Say for example here quantity and 2 times quantity is there, right? So you can drop 2 times quantity or this quantity. Any one you can drop. Any one you can drop, either quantity or 2 times quantity, your wish. Okay, so using this particular function, data frame dot core, you can find the correlationship between between the columns. So one means highly correlated, zero means okay, least correlated. One means highly correlated, zero means least correlated. That's the thing you need to remember. Okay. So drop the columns which are highly correlated and leave the columns which are least correlated. That's about the correlation matrix. This is a correlation matrix. Okay. So before processing this data, you need to check the correlationship. Okay. Okay, guys, that's about the basic statistics which we require. Okay. Tomorrow, what we will do is we will look into the mathematics which is related for the linear regression. Okay, and we will derive the formula of the linear regression. Okay, it's not the derivation of that particular formula, but we will understand that formula. Okay, so what how we will be doing the predictions, what that particular slope line will give the information about, and how the predictions are happened. And then we will take a simple data set. Okay, we'll take a small data set, and we will run the algorithm of on that data set. We will see the end to end process of processing the data, removing the outliers, knowing the what we call knowing the distributions and everything. We will see on applying the linear regression. Okay, guys. Okay, so if you are not having any doubts, guys, you can drop. We'll meet tomorrow. Any questions, guys? Any queries? Okay, then we'll meet tomorrow. Okay.